Good evening, everyone. Good evening, friends. Welcome back to our session on NLP series. So, we have understood the introduction part. What is NLP? What are the components of NLP? And we also understood the pre-processing steps, right? So, today we are going to use all the pre-processing steps that we have discussed on a use case. Okay. And this particular use case is related to text data. Okay, and our use case is we are going to focus on Twitter sentiment analysis. So in Twitter nowadays, it is named as X. So in Twitter we'll post some tweets, right? So on the social media post we are going to perform some kind of sentimental analysis. So this is a business problem, performing sentiment analysis on the social media tweets. So we are going to classify depending on the user opinions as positive, negative, or neutral. So let quickly I'll walk you through the data that we have. So friends, you see in total we have 4 columns. Okay, this data, whatever you're seeing in this particular file, is captured from X, Twitter. We have Twitter ID followed by entity, the sentiment, whether it's positive, negative, or neutral. Okay. And finally, what is the tweet? Okay. It's nothing but the content. Okay. So these are the columns that we have. And this particular analysis, we are going to help the user understand regarding the sentiment towards various topics. So Twitter, the first column tweet ID is containing an identifier for each tweet. Okay. Then entity is representing the name of the entity. It might be a product, service, or topic. Okay. That is particularly discussed in the tweet. Okay. On whatever the tweet is going to be, tweet. So as part of the tweet, we are going to use some kind of entities, right? It might be products, whatever the topic it might be, it is named as entity. Then the sentiment, this is our important column. So the label, the Y column that we have in our data is the sentiment. So we may have a positive sentiment, okay, or a negative or a neutral. Depending on the tweet, we are going to classify whether it belongs to positive, negative, or neutral. Then, and finally the tweet, right? So this is not, if you observe, it is not all the columns are in, no, apart from tweet ID, rest of the columns are in non-numeric. They are categorical. So out of all these columns, which column do you see the most important? Obviously, sentiment, because this is the one I'm supposed to, predict. See, once if I get any of the tweet, so based on the tweet, I'm supposed to give the sentiment, whether it belongs to a positive tweet or a negative tweet or a neutral one. So we have gathered the data, and this data will be used for building our model. So friends, nothing you know wrong about it. We got all these tweets from the official site, and moreover, don't go in a wrong way. Okay, so initially I'll be doing text pre-processing steps. So whatever we have discussed, it might be lowercase in text, tokenization, what parts of speech. So some of them are mandatory and some of them are optional. So whatever are the mandatory steps as part of the text pre-processing, we are going to use them on the data. Okay, and we are going to finally predict the sentiment, right? So for that, I'll build up some model. So model will be used to predict the sentiment, right? So what is the first step? The first step is obviously, importing the required libraries. So for that, I'm starting with pandas, because as we have the data in a file, in order to read that particular file, load the file, the data in the file, I'll use pandas for data manipulation, then followed by regex, for regular expressions. Since I'm working on text data, so in order to do any kind of task, I'll use regular expressions to frame my patterns, and I'll be implementing these patterns on the data. Done. Then string, just to hold the strings, we are going to import string as well. And we are importing NLTK. So this is the important library with respect to text. Whenever you're handling text, excuse me, whenever you're handling text related data, you know, you're supposed to, one of the important library that is used is NLTK, Natural Language Toolkit. So from NLTK.tokenize, I'm importing word tokenize. So we are aware of tokenization. What is tokenization, friends? Tokenization is nothing but, converting your text into small units, that is nothing but tokens. So word tokenizer helps us to convert the text into words. Each and every particular word as part of the sentence will be given as token. So I'm importing word tokenize, then TF-ID of vectorizer. From sklearn dot feature underscore extraction dot text, I'm importing TF-ID of vectorizer. So why do we use TF-ID of vectorizer? So if you see the benefit of using Spider, just hover your mouse on any of the function, it gives you a document like this. You're able to see the document. So that's how it is helpful. So TF-ID of vectorizer is uh, a step that we do for vectorization. So in the previous session, we understood bag of words, like how the raw data, the text data is being converted to numbers. In the same way, TF-IDF stands for term frequency, inverse document frequency. So the raw documents will be converted to a matrix where you are going to have the data represented in the form of vectors. So let us also import that one. Done. Then train test split. Train test split is not something new for us. So train test split helps us to split the data into two parts. One is train data and test data, and then logistic regression. So why are we using logistic regression, friends? Because I'm going to predict the output. Once after building the data, I mean building the model using the data, I'll be predicting the output. And moreover, this is a classification task. So I'm using logistic regression as well. Then the model that will be built has to be evaluated, right? So I'm coming up with classification report, accuracy score, and confusion metrics. So all of these three will be used for evaluation of our model. Then Seaborn for visualizing the data. Okay, so it's a visualization library similar to Matplotlib. I'm importing both of them. Done. And finally, label encoder is what I'm using. So what does label encoder does, friends? What is the purpose of label encoder? Label encoder helps us to convert the data, the categorical data into, numeric data. I hope you remember the pre-processing steps that we have discussed. Then uh, from nltk.corpus, I'm importing stop words. So friends, one of the key steps as part of text pre-processing is removing stop words. So I'm importing stop words function to remove the stop words as well. Then WordNet lemmatizer. What do you mean by lemmatization, friends? What do you mean by lemmatization that we have discussed in the previous class? You able to recollect lemmatizer? Any idea? Right? Stemming. What is stemming? So friends, if you haven't gone through the previous session, my sincere advice is please go through the series of sessions because this is a continuation session. Okay, so this is, uh, you know, the use case. We have understood the concept and we are trying to implement whatever we have learned on uh, the data set. So it is a practical approach. And before you apply anything practically, you should be aware of that concept, right? So just go through what is lemmatization, what is stemming. Yes, stemming is nothing but, you know, converting or bringing the word back to its base root form. Okay, if you have any word and this particular words will have some kind of suffixes and prefixes. So if you want to bring any of the word to its base form or say root form, we use stemming. But stemming has a disadvantage. The disadvantage is the word that is written as output may or may not be meaningful. So the challenge that we observe in stemming is overcome by lemmatization. Okay, so we call the root words as lemmas. So it's simple but converting back to the base word, the root word. So for that, I'm using WordNet Lemmatizer. This WordNet Lemmatizer is going to use a dictionary. A default dictionary will be used, and it refers to the words that are present in the dictionary, and the base or the root forms will be written. The root word forms will be written. Then I'm also importing the full NLTK library, and finally joblib. Joblib is for dumping and saving back the model. If you want to dump, okay, nothing but saving and loading back the model, we use joblib, right? So I'll start whatever is necessary from NLTK. Let me download all of them. The first one is stop words. Okay, so as I have discussed, friends, it comes with a predefined word. It will be a set of words in which you can customize as well. You can customize these stop words. So from NLTK, I'm downloading stop words. So this particular line, when you execute, what happens is a file with stop words will be downloaded from this library, and whatever the words that are present in this file will be removed from our text. I hope you remember what does stop words mean. Stop words are nothing but the common words, the connector words that we have in our text data. Example, a, the, in, at. Okay, and so we have some articles, prepositions, right? So those have to be removed. I'm going to download. Yes, done. Then we have WordNet Lemmatizer. I'm also downloading it. Done. So the warnings and all you can ignore. So it is clearly telling that this particular WordNet has been downloaded at this location. Okay, so it's already up to date. Since I have already these, files in my local machine, it says they are up to date. But for you, probably you will have this location where it is going to download, right? Then I'm also going to download Punct Organizer. Yes, done. So whatever is required for me, I have downloaded and I kept aside because as we start, you know, doing the pre-processing steps, I'll use one by one. So the first step is reading the data from a CSV file because I have all the tweets stored in a CSV file, friends. So all of these you see, we have it in a file, CSV file. So I'm going to read the data from a CSV file, and this is the path of my CSV file. So which function from pandas should I use? Which function should I use from pandas? Obviously, I have to use read underscore CSV because it is a CSV file. Am I right? PD dot read underscore CSV is the function. Then what does this R indicate? Why are we placing R in front of a string? It's nothing but the path. Why are we using are? You have to interact. R says, you know, to read this entire string in the raw format. See, when you execute a line, what happens in the backend? In the backend, Python interpreter, executes the line, whatever we are going to run. So what happens is the Python interpreter assumes that this particular string has some special characters. Because if you see, if you remember, we discussed special characters, backslash t, backslash r. Okay, so backslash, yes. So whatever we have the special characters, so this Python interpreter assumes that it is a special character and it tries to give an error. But are we using any special character here? No. This is my path. This is the path in which I have my data set, in which I have the file. So I'll keep R in front of the string to ensure that all this path, the entire string should be read in raw format. So I'll go and execute, and where will be the data stored? In a variable df. Let me execute that. You see, df is the variable and it is a data frame. How many rows? 74,682 rows and 4 columns. So that means we have approx 75,000 tweets. 75,000 tweets. Oh my God. So what do you see? See, entity, whatever we are going to, mention as part of the tweet, the product, it might be regarding a product, a service. Okay, so we have captured that entity and used it as part of this column. So out of all these 4 columns, the first two are not required because this is a nominal data, okay, which is giving an ID representation for each and every tweet. But these two are important, our y column and our x column. But since this is not numerical, okay, we don't have the inputs in numerical fashion, we have it in a text non-numeric fashion. We are supposed to use the concept of text pre-processing. So what does head function does? What does head function does? Head function will return the top rows and by default it will be 5. See, all the 5 rows 0 to 4, obviously 5. Then what I'm going to do? What am I going to do in line of 46? I'm going to get the information about missing values. Okay, so df dot is null. Is null is a function which goes and checks each and every cell present in df data frame. Okay, so it just returns either true or false. When you say dot sum, all the true values will be summed up. Okay, then let me execute this so that I'll get the count of null values in each and every column. So seems like there are no null values in the first 3 columns, but the tweet, nothing but the content column has 686 null values. There are 686 null values. And df dot columns will return what? Df dot columns will return column names. Since we have 4 columns, all the 4 columns names were being written. So now let us start our pre-processing steps. From here, the actual, story starts. because we have started the pre-processing steps. So far we just loaded the data set, and on this data we are trying to, build a model to do some kind of sentiment analysis, right? So let us start the pre-processing step. What is the first step that I'm doing here? I'm taking content column from DF. So friends, it is very easy. If you focus, it is very easy. From DF, okay, we have content column, right? The, last column. What I'm doing, I'm converting this to str dot lower. So in simple, I'm converting the text to lowercase. So why? That is what we have understood yesterday. If you see here, some tweets are in uppercase and some tweets are in lowercase. And in some tweets, we have combination of both. See. So I'm going to convert the text to lowercase. Let us go and use lower function. That's it. Then once if it is done, I'm going to check whether the content has been the column within the content column, whether the tweets got converted to lowercase or not. So for that reason, I'm using head function. Yes, I see each and every value present in this content column has been excuse me, has been converted to lowercase. Done. Then what am I doing? I'm performing as type function, okay, on the content. So I'm converting it to string data. So you remember typecasting? So I'm using typecasting. I'm performing typecasting and I'm converting the values present in the content column to strings. And where am I storing? I'm storing the same column. Why? Because if I convert to string, then I can start my, rest of the actions. See, right? Next to that, on the same column, okay, I'm going to use substitute function, and wherever I have these words, if I have http slash or www dot slash https, so if I have such kind of words in the tweet, I know it has to be substituted with nothing, and it has to be stored in the same column. Okay, because in some tweets we also have http. Okay, then we have got it from websites, right? So we also see www dot. We are removing all of these URLs, friends. That's it in simple. So let me do that and let me get the count. I mean head. So done. Then what am I doing here? I'm handling the non-string values. Okay, if we have digits within this particular column, we have within the content column, we also have digits. So I'm using regular expressions library. So why did we use regular expressions is to define our patterns. Okay, if they are digits in the string, I mean within the content, they are supposed to be converted to str. Done? Yes. Then if you have any null value, even replace them with the same. Okay, I'm applying the same and I'm going to handle the non-string values. So we know isNA. isNA is going to check whether null value is present in cells or not. isNA, isNull, we have multiple functions. In the same way, we have fillNA. FillNA is going to fill that particular cell with a value, with nothing, that's what. Right? Then what am I going to do? If there are any numbers present in the content, I'm supposed to remove them. Okay. So if it is a number, substitute with nothing. I'm using sub function from RE library, nothing but regular expressions. then I'm getting the count, I mean head. Okay, so all these are basic pre-processing steps that we do it on text data, and it depends. See, here I have a combination of numbers and I have URLs, the links and all. But in other data you may not have. So probably there you'll not use this. So obviously you'll convert it to lowercase, then probably you'll start doing tokenization, then lemmatization and all. Then, if I have any punctuation marks, so I'm removing the punctuation marks as well using this, punct. So I'm using this from the content. Okay, I'm going to use translate from string dot punctuation. Okay, and this will ensure it removes the punctuation marks present in that each and every tweet. Okay, and also I'm going to return the head, the top 5 rows. Done. So far, we removed punctuation marks, the numbers, and the links and all. Now, let me start with tokenization. Let me start with tokenization. What we are going to do as part of tokenization? Tokenization is nothing but converting the text into small pieces, nothing but tokens. So each and every value present in content, nothing but each and every tweet. Okay, I'm going to apply word tokenize, nothing but word tokenization on this column, and the result has to be saved in the same column. Let me apply it. So it's taking time. If you see, word tokenization will convert each and every sentence to singular words. So wherever there is white space, so based on the white space it is going to convert. See, so I spent a few hours, so on. So in this way, you're able to see each and every word as a token. And Akhil, why there is no full stop, why there is no comma between each and every word? Because, friends, I have already removed the punctuation marks. You remember, right? So I removed the punctuation marks. Now, within these tokens, there might be some stop words. Yes, I clearly see there are some stop words within each and every tweet. I, am, to, the, all of these are stop words. So let us remove the stop words, the connector words. For that, I'm going to use, stop words that we have, imported. From stop words, I'm using words in English language, and these words I'll convert to a set. So these are the list of stop words that I'm going to use. So if these are found in the tweet, we are going to remove them from the tweet. I hope it's making sense. So these words, that is 198 words, should not be part of, I mean, if they are part of any of the tweet, those words will be removed. Okay. For that, I'm writing the logic using lambda function. So you see, we have discussed comprehensions. This is a list comprehension in which we have for word in tokens, nothing but these tokens that we have in the content. Okay. If word not in stop words, if they are not in stop words, only those words should be part of the content henceforth. If not, if it is part of this, stop words, it will be removed. So it will be filtered. I'll execute, I'll open. See, I'm storing the same column, right? See, do you see any stop words here now? Yeah, actually I see am, but am is also again a stop word, right? Why do we have still in the data even after removing them? Hold on, friends. This is my list of stop words. Where is I am? Show me I am here, first of all. If you have it, that will be removed for sure. But if you don't have it, we cannot remove manually. Let us check. If we have I am, okay, So that will be removed for sure. And if you don't have, it will not be removed. We have I have, you are, very about is needed, I will. So we have all, but I don't find I am. Ah, hold on. Akhil, what rubbish you are talking? You see, I have I am, but why it is not removed from the content? Is this I am and this I am both are same? No. Then how does it understand that it is I am? So that means only if it is present in these list of 198 words, in this set of 198 words, only those will be removed as stop words from your tweet. This I am and this I am both are not seen. The I am that I have in stop words have, you know, apostrophe. But do you have an apostrophe between I and am in your content? No. So both are not same, friends. That is the reason, this is not removed from the content, nothing but from your tweets. Making sense? Yes. So once after removing the stop words, I'll go with the lemmatization. What is the purpose of lemmatization? Lemmatization helps us to, you know, convert the words or reduce the words to its base form, root form. So let me initialize wordnet lemmatizer, and this wordnet lemmatizer I'll be applying on the content column within DF. See, for words in tokens, for words in this content, each and every tweet, it has to undergo lemmatizer dot lemmatize of word. So it takes each and every word and uses that lemmatization. The function that we are using is lemmatize. What is lemmatizer actually? Lemmatizer is nothing but wordlet lemmatizer, the function I have stored in lemmatizer. Okay, so that will be stored back again to df dot content. So let me also explain it before. You see here, we have getting, I am getting. So let us see how getting will be converted. What will be the base form of getting, or what will be the base form of coming? The root form, the root word, the base word. Friends, I need your answers. Don't sit idle. Okay. What will be the base form of getting, coming? No one seriously? Because as we are using all the text pre-processing steps, it's better if you interact. We can make the session very great. Yes. For getting, the base form or the base root will be, the base word will be get. For coming, the base word will be come. So you are adding ing. Am I right? So now on these words, I'll use lemmatizer. I'll use lemmatization concept and let me see the output. Is it done? Yes. Now let me open it. Is it still the same? Is it still the same? Yes. So probably for these words, it is not done, but for the rest of the words, it has done. Okay. So lemmatization has been performed on each and every tweet of the data. Okay. Then what you are going to do? Once after completing lemmatization, I'll join back all the strings. So once after completing the pre-processing steps, now I take each and every token present in each and every tweet, and these tokens will be joined with space. I'm using join function, and these tokens will be joined. Let me open and show it to you. So this is how we have done. Initially, there is a tweet, and that tweet got converted to this fashion. Initially, we applied lower casing. Then what did we apply? We removed punctuation marks, we removed numbers, we removed the links, okay, the URLs and all. And finally, we started removing, we worked on stop words, we got tokens, we removed stop words. Then on these tokens, we applied lemmatization, and the output is like back to a text. So this particular text, I'll start building the model. For that, the first step is splitting X and Y. So in X, I'll have only the content, that particular column, and in Y, I'll have only sentiment, whether it is belonging to a positive or negative or neutral kind of, sentiment. Now, what is the percentage of test that I'm going to take? For test data, I'm taking 20%, and obviously train data will be 80%. So let me do it as well. So here I'll get the values. So training set size is this much. Okay. And the test one is this much. So it's making sense, right? 80% and 20%. Together it is 100%. Now let me convert the data into vector format. Okay. For that I'm using TF-IDF vectorizer. Okay, so the full form of TF-IDF vectorizer is term frequency inverse document frequency. Okay, and the maximum features that I'm going to take is 5,000, the most important 5,000 features. Okay, the words, nothing but. I'm initializing it, and this particular TF-IDF vectorizer, I'm going to fit on the train data because it holds what? The content. So let me fit and up transform the data, and I'll do the same on the test, X test. Okay, so once after completing, you see X train, X test, vector form. So this is the vector form, friends. Probably it is an object created, and you cannot, it's a CSR matrix. Okay, so we cannot display this, but this is the size if you see. So for 5,000 words, okay, for across these 59,745 rows, you'll have the frequency. The term frequency, inverse document frequency is what it will be calculated. On this data, I'm going to build a model, and it is logistic regression. So the purpose of logistic regression is to classify. We generally use logistic regression for a classification task. So I'm initializing the model. The first I'm initializing the function, and this function I'm storing in model, and that particular function will be used to fit on my X train vectors and Y train. So it's nothing but I'm passing the train data, and the model gets fit. So it starts learning the patterns. Once after learning the patterns, now I'll use that model to predict on X text vectors. So the vectors that we have in the text data will be used to get the predictions. And where are we storing the predictions? In YPred. And the YPred, we are storing the predictions. So classification report is what I'm going to get next as part of evaluation, because the model got trained, we got the predictions. Once if you have predictions, we also have actual. So if you have actual, if you have predictions, start getting the loss. Calculate your loss function, cost function. Okay. So for that, I'm starting my evaluation. Okay. Whether the model, the results that we got, the predictions that we got are good or not, I'm going to use classification report to get the output for test data. Now let us have a quick look. What is the values? Are they good enough? Oh my God, there are 4 different classes. F1 score is not that much good. It's average, because the range of F1 score is 0 to 1, and if the F1 score is close to 1, that we can say it is a good model that has built. Okay, even the F1 score is not good, and the recall and the precision values are also not that much good, but satisfied anyhow. So I'll also get the accuracy for the same predictions and the test, y actual and y pred. So let us print it. Oh, it is just 67%. Okay, approx 68% is the average that we, the uh, accuracy that is what we observe. Then let me take a normal text. So if this is the tweet that I have took, okay, and this particular tweet I convert into vectorizer format, okay, and let me use my model to predict. So this is my text, my tweet, and this particular tweet, what I'm going to do, I'm going to apply vectorizer. What is this vectorizer? Nothing but TF-ID of vectorizer. Okay, so when I apply it, I'll get the vector form of the text. Done. So to this vector form, I'll use my model to predict. I'll use my model, logistic regression, to predict what kind of sentiment it is going to predict. Let's see. So it says, it is a positive tweet. Let us go through the tweet. I love this product. It works perfectly. Yes, it is a positive tweet that we had from the user regarding a product. But somehow we are not satisfied with the results because it is just only 68% on accuracy. Accuracy is just 68%. So that means there is a chance of 32% going wrong. Error is 32%. For that reason, let us not stick to logistic regression. We'll use random forest. So we also have under ensemble techniques, random forest, right? So let us go and use random forest to build a model instead of logistic regression, right? So what I'm going to do is, but random forest requires the output in numbers. But do you have numbers in your Y column? No, I have text. In your Y column, in your sentiment column, you have text, categorical values. These categorical values will be converted to numeric values. Why? Because of my random forest, algorithm, which requires the output in numbers, numeric format. I'm going to convert the output to numeric form. For that, I'm using label encoder because label encoder is generally preferred to encode the data in output column, Y column. So I have initialized label encoder to label underscore encoder, and this becomes my function. I'll use it on my Y train data as well as Y test data to fit and transform so that the output will be converted from non-numeric to numeric. So let me show it to you. Y train encoded. Yes, this is how it encodes. Previously, we have positive, negative, neutral. But here, this time, do you have any number? I mean, you have any text? No. So now I'll import random forest classifier from sklearn.ensemble and the metrics anyhow we have imported. Accuracy score, we'll do it one more time. So I'm initializing random forest classifier. So this works similar to decision tree, but it uses many decision trees to actually work. So the number of trees that I want to go with is 100, and the random state always this initializes with 42. Okay, so I have initialized random forest classifier function. Then I'm making that particular function to fit on the train data. Am I passing? See, under train data, inputs I am passing in vector form and train Y. Output I am passing which is encoded. Okay, if you see, the encoded Y is what I am passing, friends. Now I'll execute. Excuse me. So it is under process. Okay, it is learning the patterns within the train data. Once if it is done, you can get the predictions on test data. Let's see what will be the accuracy score and all. We'll see. Instead of logistic regression, we have changed our model to random forest, and let's see how our results would be like. It's taking good amount of time because we have a lot of data, and Even we have went with more number of trees. So that is the reason it is taking time. So friends, if we are using GPU, probably it doesn't take more time, but still CPUs, no, because of the computational burden and all, it may suffer. So if you have good amount of RAM, yes, it executes in faster mode. It is going through each and every record present in the train data. Okay, it understands both the train X inputs and output and identifies the pattern, because only if it learns as part of this, you know, journey, it starts predictions. Okay, so it is taking time. That's okay. Yes, you see, it's done. Now I'll use the model which got trained to predict on text data. So let me predict on the text data where I pass only inputs. I'll get the predictions. So using these predictions, let me calculate the accuracy. So this is the accuracy score that we got for random forest algorithm. So when I tried building the model using random forest, so this is the accuracy. It is 87.31 percentage. Previously it is 68. So 20% it has increased on the test data. I'll do the same. Okay. So for that, I'm going to, predict the sentiment. Okay. I'm using the model which we have already built. I'm predicting on the new text. So we have previously taken a text, right? So using that, I'm going to use it and I'm going to predict how it is going to give. And let us see. It says predicted sentiment is 3. 3 is nothing but positive, friends. Okay. So because it predicts only out of those values. Okay. Since this is random forest, it is not predicting the class directly, but the number, right? Yes. So the encoder that we have used is label encoder, right? So using that, what I'm going to get, I'll get the original class of it. So let me print it. It is positive. 3 is nothing but positive. That's what I have told. So I just, used an inverse transform function which is present in label encoder to get the original class value. So this is something for our understanding we have used. That's it. But in general, not required. Okay, so the value, the output that you get here, 3 is representing positive class only. So either you are using logistic regression or random forest, the output for the text that we have took, the tweet that we have took is positive. The sentiment says it is positive, right? Now, I'll also get the confusion metrics on the test data. Okay, so let me also visualize the confusion metrics. So it's done. So friends, you can also create, beautiful visualizations like this. I'm using Seaborn and Matplotlib together to get the visualizations. In the same way, whenever you're going to get some kind of normal things, you can make it in a beautiful way. See, I can also get the confusion metrics to my console, but that will not be that much attractive. But since I used data visualization libraries like Matplotlib and Seaborn, I can visualize it in a beautiful manner. So if you see, there are in total 4 classes: irrelevant, negative, neutral, and positive. For all these four classes, we have the true sentiments and the predicted sentiments given as a matrix. So irrelevant predicted as irrelevant in these many cases. Negative uh, tweets predicted as negative in 4070 cases. So the diagonal represents your true values. Okay. So if you take this is true positive, all them will be true negatives. Okay. So that's how you are supposed to interpret the values. And we'll also do a separate, I'll do a small video for confusion metrics in the upcoming days. How you are able to, how you are supposed to interpret a confusion metrics for a multi-class problem. Because this is a multi-class problem. This is not two class. Okay. For a multi-class problem, how you are supposed to understand confusion metrics is, a bit confusing. You'll feel some kind of, you'll get confused, but that's okay. I'll do a video and I'll post it in our YouTube channel. So successfully we are done, and the last step is to save the model using Jabli, right? So hope you have understood the concept today. We have took tweets from the Twitter, and we are going to predict the sentiment, whether it belongs to a positive, okay, or negative or neutral. Okay, we are going to predict. So initially, since it is text related data is what we have, we applied all text pre-processing steps, converted into numbers using TF-IDF factorizer, and then we are able to use the same algorithms. Classification algorithms will be used because this is coming under classification, right? So in the upcoming days, let us also go and we'll come up with more use cases under the NLP, how you're supposed to do web scraping. So if you have the text present in a website, okay, so how web scraping is done, we'll take, we'll do it in our next session. So if you have any questions, yes, shoot your questions. If not, I'm done for the day. Uh, Moreover, thank you so much for joining and making the session interactive. If you feel this session it went really well, you know, hit on the like button and do share across your connections, your family groups, and across your friends. Ask them to learn these important topics as part of AI, because NLP is a crucial skill as part of AI. Okay, so we have also provided a feedback link. Do give a valuable feedback before you leave, friends. So that's all for the day. Again, we'll meet in the next session. Until then, take care.